Can a machine think like Einstein or Newton? It seems like a far-fetched idea, doesn't it? But buckle up, because scientists at the Forschungszentrum Jülich in Germany have managed to do just that. They've trained an artificial intelligence, or AI, to think like these renowned scientists. So what does this really mean? Well, this AI model is not just any ordinary machine. It's a whiz at recognizing patterns in complex data sets and then, hold your breath, forming a physical theory around them. Yes, you heard it right. It's like having a mini Einstein or Newton inside your computer, tirelessly working to make sense of the world around us. Now, if you're wondering what AI is, it's a kind of smart technology that can learn, reason, problem solve, perceive, and even use language. Its potential is truly mind-boggling, especially in understanding complex data sets that would take humans years, if not decades, to figure out. So, we've just started delving into this fascinating development. Let's delve deeper. So, how did these scientists manage to accomplish such a feat? Well, let's dive into the process and break it down. In essence, the researchers at Forschungszentrum Jülich in Germany used a technique that centers around a neural network, a key component in artificial intelligence. Picture a neural network as a web of interconnected nodes, similar to the neurons in our brains. This web is designed to recognize patterns in data, much like how our brains recognize patterns in the world around us. For this project, the scientists fed the neural network complex datasets. These datasets contained a myriad of interactions and behaviors that would baffle even the most seasoned physicists. But for our neural network, it was a walk in the park. The network sifted through the data, recognizing patterns and mapping the complex behaviors into a much simpler system. Now here's where things get interesting. Once the neural network had simplified the complex behaviors, the scientists then created what's known as an inverse map. Imagine you have a map that guides you from point A to point B. An inverse map, on the other hand, would guide you from point B back to point A. In this case, the inverse map was used to trace back from the simplified behaviors to the original complex behaviors, but with a twist. As the inverse map was created, the trained AI began to develop a new theory, a theory that could explain the complex behaviors in a simplified manner. It's akin to understanding the intricate mechanisms of a clock by breaking it down into its fundamental gears and springs. With this approach, the researchers were not only able to study a large number of interactions simultaneously, but were also able to extract the theory learned by the computer and the language it uses to explain interactions between system components. This is what they've aptly named the physics of AI. And there you have it, the science behind an AI that thinks like Einstein and Newton. But what does this all mean? Now, the question arises, why does this matter? What's the significance of this research? Well, the answer lies in the sheer potential of this scientific breakthrough. The ability to study a large number of interactions simultaneously is a game changer. It's like being able to understand the melody, harmony, rhythm, and lyrics of a symphony all at once. This opens up a whole new world of possibilities for research in various fields, from physics to biology to even social sciences. But that's not all. What makes this AI model unique is the way it learns. It doesn't just absorb patterns like a sponge, it builds a physical theory around them, just like the great scientific minds of the past did. It's not simply data crunching, but a process akin to understanding, of piecing together the puzzle of complex systems. Even more fascinating is the researcher's ability to extract the theory learned by the computer. This isn't just about the AI spitting out results, it's about understanding how the AI arrived at those results. They've essentially been able to translate the AI's language, its unique way of explaining the interactions between system components. This has the potential to revolutionize the way we approach and understand complex systems. It's like being handed a map and a translator for a previously uncharted territory. This could lead to breakthroughs we can't even begin to imagine yet. So, while we're still far from having a machine that can match the genius of Einstein or Newton, this research surely represents a significant step towards understanding the world in a whole new way. Who knows what the future holds?